number 6. This is our function x cubic minus 3x, and we are going to solve for x as we are getting the derivatives, the first one and the second one. Then we are going to get the concavity test and so on to get all the answers for the questions.
For point A, we have to calculate the restriction in domain. So we have no restrictions because it's a cubic function, so they don't exist. In the domain is x belongs to all real numbers because we have no restrictions.
Point number B is to calculate x and y intercepts. For the x-intercept, we solved for x and we got two values, one positive and one negative, and we got 2 points. Point number A, minus 1.73,0, and point B, 1.73,0. And in y-intercept, we substituted x for a 0, and we got that the y-intercept is 0,0. This point, it's also an x-intercept because it passes through the origin.
The next problem is to find if there's symmetry in the function. And as we were solving, here you can see the procedure, we realized that the result is not the same as the original function, but still the both change of sign, the result is the same between them. Therefore, it's an odd function.
For point D, we have to calculate the vertical asymptotes. So, because the domain of our function is x belongs to all real numbers, we have no restrictions, so we have no vertical asymptotes. Point E is calculating the horizontal asymptotes. We calculate them with limits, limit of x when it is infinite and x when it's minus infinity, and it has no limit, so it has no horizontal asymptotes.
Our next problem is to obtain the first derivative. Then we solve it, and our derivative is 3x squared minus 3, and here is like factorized. And then we have to perform an ID test to the first derivative. We start with the t-chart to see how does the function works, how does it may look when it is graphed, and then we graph it, and we can see the type of test, which is increasing, decreasing, critical points, maximum point, minimum point. And the increasing works like from the point 0 to infinity, it's going upwards, therefore it's increasing. And when it's decreasing, it's going from minus infinity of x to the point 0. So it's going downwards, therefore it's decreasing. To obtain the critical points, our derivative equals 0, and we obtain these 2 points, which is minus 1 and 1. Therefore, those are our critical points, and our maximum point is x equals minus 1, and our minimum point x equals 1. Then we obtain the second derivative, and we use the first one to obtain the second one, which is 6x. And then we use a t-chart with the same x values to see how does the line will look like. We know there is a simple line because it just only has one x, and here is the points. So then we graph it. Here it will look like something like this, and then we make a concavity test. We use first the inflection point. To obtain the inflection point, we equal to 0 the second derivative, and we obtain that the inflection point is 0. Then you can see that what is left to the inflection point is negative. Therefore, the concavity there is going to be negative. So here, when the concavity is negative, we have that x is less than 0. And when what is to the right of the inflection point, you can see that is positive. Therefore, what is positive, the positive concavity, you can see that x is higher than 0.
were bold and